Ransomware on Amazon S3 buckets. So this is a pretty interesting type of technique that is used by the bad actors. And this happened a couple of months ago, but it is still applicable today. And I will be showing you today how you can, of course, trigger the kind of ransomware on the S3 bucket. And number two is how can you detect that as a security person, a cybersecurity professional. So you can see over here, I am on CSA. So this is Cybersecurity Agency of Singapore. And we have ongoing campaign targeting Amazon Web Services, S3 buckets. And there are reports of a ransomware campaign and so on and so forth. So I think the most important part of this is the initial access. How did the bad guys gain access first? So the number one reason, again, as you can see here, is typically gained through compromised IAM credentials or overly permissive IAM rules. So say, for example, you have a decentralized identity and access management. You allow developers, users to create their own access keys. They can then, using those IAM user access keys, be able to access over an S3. And they're also permissive at the same time. Or your IAM rules are excessively permissive, meaning that you're giving, say, for example, all access to S3 buckets and to possibly even all S3 buckets within that, say, AWS account. As a result of that, what the bad guys can do, the bad actor, your best friend forever, Mr. Hackaloy, is they could encrypt the objects using their own encryption key. And as a result of that, they can ransom the organization. Because when the organization tries to retrieve the S3 bucket object, guess what? It's encrypted. They don't have the key. And without the key to unlock it, they are now having to pay a ransom. So that's how pretty much it works in terms of this campaign, and I'll show you how it looks like. So before we go into the demonstration, I want to take this chance to show you how that looks like. So first of all, of course, your best friend forever on the right, Mr. Hackaloy, would have obtained some kind of access keys. All right, so the access key is now being obtained because either it's being exposed in some public repository or it's being saved into like some kind of config file, or maybe other different types of places like Systems Manager, Parameter Store, and so on, or even the Secrets Manager that's accessible, or perhaps through a phishing attack. So over here, what happens is once the hacker gains access to the access key, they can use that and then be able to obtain the objects within the S3 bucket. So they will be probing for like listing buckets, listing objects within the bucket, and then with that, they will use their own encryption key. So let me go ahead and try to draw a key over here. So it looks like a key. All right, something along this line, okay. All right, that looks pretty good. And then with that, they can encrypt it with their own key and then re-upload the objects, overwriting them. And when the legitimate user who wants to access into the objects, say for example, you have Mr. Script Kiddie Loy here, who wants to access into these objects, he realized that he's blocked because he does not have access to the encryption key. And this is what we call as the S3 server-side encryption with customer provided key. Okay, or maybe hacker provided key. So right here, we are on Kali Linux, and I'll be issuing the commands from here. And the first thing we do is once we have access over into, say, either the access key or into the IAM credentials, all I have to do is enter, say, for example, AWS S3 ls S3 followed by hacker Loy test bucket. So this is like the target bucket that we're going after. And from here, say, oh, let me just go ahead and hit the enter for this one, S3. And you can see the list of objects. And the one that we are targeting, say, for example, in today's case, can be like password.txt. And I can do a AWS S3 copy password.txt. All right, sorry, let me just go ahead and copy from S3 password.txt over into the current directory. And once that is done, we can read what is inside the file. So for example, over here, I can do the following. So what I do is cat password.txt. So we're able to read the file after we have downloaded it. So you're the bad actor. you're the bad guy, you downloaded the file, and what you want to do now is, say for example, you can upload anything else here, all right? So what we can do is, say for example, AWS, all right, S3, and then we can copy whatever is the encrypted object, and then after that we just overwrite onto it, okay? So whatever with the same key, the same name that you upload over in an S3 bucket will automatically be overwritten. So with that, we then first have to create, in this case, an encryption key, all right? So the encryption key will be hosted on premises or on our current computer that we're using instead of it being available directly in the AWS account. So for example, in this case, I can do the following by creating the key. All right, so the key can be created by using, say, OpenSSL. So over here, I can have the following of dash out. Say, in this case, we're going to call it the hacker loy key dot bin, and then 32. I hit enter on this. And then I can say, for example, ls-l, and we can see that the file has been created. So we have the hacker loy key.bin. So what we want to do now is to go ahead and encrypt the file and re-upload that back over into the S3 bucket. So all I have to do is to run the following AWS S3, right? Copy. In this case, we have the file that we're targeting, which is password.txt, S3 followed by hacker loy test bucket slash. In this case, we have password.txt. All right, and then we have the option of SSE-C, so we're providing our own key, AES256, and then followed by, in this case, we have the target file, which is SSE-C-key, followed by file B, and then this is the file that we have created, which is hackerloykey.bin. All right, so once you have that, all you got to do is just go ahead and hit enter on that. And done, all right? And if you notice something that's really interesting, now that we have uploaded this specific file back over into the same S3 bucket, is that when you try to download it, it doesn't work. So say for example, I do a AWS S3, and then I copy the following, which is S3, hackerloy task bucket slash password.txt, and over into the current directory, I hit enter on this. It does not work because it is expecting us to provide the encryption key. All right, so in this case, it doesn't work. So with that in mind, it means that we've overwritten the file, and now the user is no longer able to access that file because it's been encrypted, okay? Furthermore, even the metadata within it, say for example, I enter AWS S3 API hit object dash dash bucket hacker loy test bucket followed by the key, in this case of password.txt, I hit enter on this. Likewise, it doesn't work because we have to supply the encryption key that's been created inside our Kali Linux machine. Furthermore, when you navigate over into the S3 bucket that contains the file, so in this case, if I hit over into password.txt, I click over into it, and as I scroll down further, you start seeing error. The reason why there is an error is because the encryption key is now no longer with AWS. Say for example, either using the one that is provided by default from S3 or using key management service, either one, the key is not now accessible directly from AWS, and you have to supply an encryption key that is residing in Kali Linux or in the hacker's computer. Now, what's really important that you understand here is in terms of detecting this kind of technique that is in use. So over here, I have a specific CloudTrail trail that is created inside the account. And if you scroll down further, what you need to enable, particularly for your AWS accounts that would have containing, say, some of the sensitive S3 buckets or critical S3 buckets that could have your, say, database backups, your videos, photos, or any of those sensitive information, this is a place where you want to click onto edit. And you want to ensure that you have data events being enabled. And then when you scroll down further under data events options, you have the resource type of S3, all right? And you can see, for example, in our case, log or events and so on, and you save changes for that so that when there are situations like this where they put an object onto it, into your S3 bucket, you're able to detect that they're using a specific mechanism over there. So right here on Amazon Athena, they can help us query into CloudTrail looking for specific telltale signs or indicators. So in this case, you can see the following, where we're looking specifically for the event source of S3, as well as the event name of put object, and the request parameter that has the server-side encryption customer algorithm. So when I run this, if I scroll down further, you can see that we have 4 results, okay? And under the response elements, of course, you can see over here, we have AES-256, AES-256, and once again over here, and you can see that I was targeting, of course, 2 files, right? So one of that is password.txt that we saw in the demonstration, and of course, I also have a separate one, which is secret.txt. Now, the good news is, when you have the resource control policy in place, you can likewise see something over here that will demonstrate that we are blocking the access. All right, so you can see over here, we have the access denied. So what you saw earlier was for detecting such attempts or API calls. But what we can do is we can also inject preventative controls or preventive controls using resource control policy. So this is a new feature with AWS organizations. And you can see the content over here, right? So what we have is deny all principals who attempt to put an object, and you can see right here when they use, in this case, all right, X-AMZ, server-side encryption customer algorithm. So once you have that, all I gotta do is go ahead and attach this over into a target account. So the target account that I have here is developer Loy. So I can select onto that and I click attach policy. So once this policy has been attached, when any principal tries to go over into any of the S3 buckets within this AWS account and they run the same AWS command line, they will fail. So you can see over here, I'm headed back into Kali Linux and I have the same file, which is copy password.txt, the same command with the SSE-C AES-256. I hit enter on this and can see the following feedback coming from AWS, which is, here you go. So it states the following: an error occurred, access denied. When calling the put object operation, all right, it's not authorized to perform because of a resource control policy. So if you see that there is no use case across your AWS organizations or organization units where a user, a principal, is allowed to use their own encryption key on the put object, then in that case you can place a preventative control like this one into your AWS accounts.